Making predictions. All right, guys and gals, we're going to make some predictions here. All right. Which represents a greater amount, 0.4 or 3.9? Hopefully you can see 3.9. Oh, 3.9%. I'm sorry. I was comparing them as decimals. All right. A bag contains 9 letter tiles. There are 5 E's, 3 T's, and an X. What letter would you most likely draw? Hopefully you would see that since there are 9 in there, and there would be 5 E's, 5 out of 9 is better than 3 out of 9 or 1 out of 9. So it would be an E. All right. Today we're going to use probability to predict events. Prediction. A prediction is something you can reasonably expect to happen in the future. Whether forecasters use several different methods or of forecasting to make predictions about the weather, the one way to make a prediction is to use probability. Lawrence finds the experimental probability of his reaching first base is 40%. So he comes up to bat 10 times, he'll reach base 40% of the time, which is 4 times. Out of 350 at-bats, how many times can he expect to reach base? So you can do this 2 ways. You can take the 350, and hopefully you remember how 40% is equal to 0.4. 1, 2. If you take the decimal times the total that you want to see how many we have this, and you multiply them, so that'd be 0, 12, 14. Okay. Move this 1 spot. 140 times is the amount of times he would reach base. About. That's his estimate, that's his prediction. If you want to think logically, 40% is a little bit less than 50. 50% of 350 is 175, so we're a little bit below that. That seems to make sense. My suggestion, change the percent to a decimal, multiply it times that total number of at-bats. 140 would be their estimate. Let's see what they show. Write an equation, okay? 4/10. They chose to write it as a fraction. 4/10 is the same as 0.4. When you multiply 4/10 times 350, you get 140, just like when we multiplied 0.4. I think doing the decimal is much easier. You can also use the fraction. 4/10 is equal to 40% is equal to 0.4. All right? We could set up a proportion. 4/10 over 350. All right? And we could cross multiply and divide. And we get 140. That's the second way you could do it. They don't show my method, which I think is silly of them, but I showed you that third method, which is change it to a decimal and then multiply. Malaya finds the experimental probability of her scoring a goal is 20%. Out of 225 attempts, how many times can she expect to score a goal? Again, I would take the 20% because that's the amount I want to find. I'm going to change it to 0.2. Okay? And I'm going to take 225 times 0.2. 4, 5. All right. And 4. Don't forget to move this. So, when I do that, out of 225 attempts, I'll expect her to score a goal about 45 times. 20% is 1/5. So if I divide 225 by 5, it will do the same thing, and I get 45. Okay? So, I took my method, I changed it to a decimal. That decimal represents the percent. I took that times the number. It gives me the amount that represents that percent. 45 is 20% of 225. Okay? So method 1, we can set up an equation. 2/10 times 225 equals x. They wrote 20% as 2/10. And when they did the math, you see they get 45. That's what we got. They changed it to a fraction. We changed it to a decimal. Both do the same thing. Or you can set up a proportion. All right, 2/10 equals x over 125. So 2 out of 10 goals will be scored. That's a way to represent 20. So how many goals out of 225? Then you can do your cross multiplication. Okay. Then you do your division to get the x all by itself, and you get 45. A spinner has 8 sections of equal size. 3 sections are labeled 1, 2 sections are labeled 2, and the others are labeled 3, 4, and 5. In 50 spins, how often can you expect a spin of 1? Well, we need to first figure out how many sections were there. 8. That's our total number of choices. What is our desired choice or the choice we want? 3 sections are labeled 1, 2 sections are labeled 2, and the others are 3, 4, and 5. So it kind of looks like 1, 1, 1, 2, 2, 3, 4, and 5. That's what that spinner looks like. How often can you expect to spin a 3? Well, 3 of the 8 are what I want, so 3/8 of the time. We found out how often we can do that. Now, if we spin 50 times, how often will we get that? Just like before, we can take 3/8, which is that percent, but it's just written as a, that's our prediction, percent written as a fraction, and we can multiply it. I like to reduce first, so that's going to be 2, it's going to be 25, okay? So, oh, excuse me, that's going to be 4, I believe. All right, so that would be 75 over 4, okay? And when we do our math, then we'll come out here. They're going to probably set up a proportion, and they're going to get the answer, hopefully, that we got, okay? So, spinning a 1 is 3/8. That's what we started with. How many of those out of 50? They set up a proportion, all right? When they do their proportion, 3 times 50 and 8 times x. Okay. 150. Divide each side by 8. 18.75. If you take 75 and divide it by 4, you're going to get 18.75. They do work out the same. You can take this times the 50 and get it. It is the same as setting up that proportion. All right? You would just have to walk through, and I don't believe, or shouldn't, I should be sorry I did not do that. Let's just prove that the 75 divided by 4. That would be 1. So that's 35. So that would be 8. That would be 32. All right, so that would be 7. That would be 28. And that'd be 5. That was just showing you that my way did come up with exactly the same answer. Okay? Round to a whole number if it makes sense to give the situation. You can't have 0.75 of a spin, so in that last situation we would run around up or round down. A spinner has 8 sections of equal size. 3 are labeled 1, 2 are labeled 2, and the others are 3, 4, and 5. How often would you expect to spin a 2 in 50 spins? So, there are 8 total choices. 2 of them are 2s. So if we take this probability and we take it times our total number of spins, okay, we would get 100 over 8. 100 divided by 8 excuse me, there's 16. Gotta know how to do division with decimals. So 12.5 times we can expect to spin a 2. That doesn't make sense. Since it's 12.5, we could say 13, or I'll accept 12. Around 12 times would be the expected answer, okay? The probability times that total number of spins will give us how many times we're likely to come up with that number we want, okay? They're going to show you, set up a proportion, okay? All right, so 2/8. 2 out of 8 times you'll spin a 2. So how many times out of 50 will you spin a 2? All right, we're going to cross multiply. And you're going to see, 100 equals 8x. Divide each side by 8. And we got that. Anytime you have a probability or a percent, if you take those times the total number, that'll give you the number that represents them. Okay? The Sine family is planning a 7-day tropical vacation during July or August. The island destination they have chosen averages 21 days during this 62-day period. If the Sines would like to avoid rain on at least 5 days of their vacation, should they go to this spot or choose another one? So, 21 days out of 62 days, it rains. They want to avoid rain on at least 5 of their vacation days. So 5 out of 7 days they would like no rain. So we have to think, no rain on 5 out of 7 days. This is the number of days it rains. This is the number of days they want dry. So we're not comparing the same thing, okay? What we should compare is the number of days that are wet or the number of days that are dry. If this many days are wet, how many days are dry? Oh, if these are wet, these are wet, the other option is dry. So 41 out of 62 are dry. I got that by taking 62 minus 21. Oh, because remember the probabilities have to add up. Then we would have to see, are these two equal or which one is greater? Well, I could take, my apologies, 5/7 and I could think, okay, well, if I take this times 9 over 9, that'll get me to 63 and 45. We want 45 dry days. They're only able to give us 41 out of the 62. It would likely be that they'd need to choose another spot. So let's see. That is my way that I was thinking about that problem. Let's see how they think about it. All right, understand the problem. All right, 21 out of 62 days of rain. They want 5 days of their vacation rainless. All right, on average. 21 out of 62 is how many out of 7? So they took away that 5 and, all right, they're going to do their cross multiplying. 2.73. That's how many days they will have that are rainy in a 7-day average. So that's more than 2 rain days, and they don't want to do it. They were just giving you a way to compare, as was I. Okay? So, look back. All right? Since both ratios are about 30%, the answer is reasonable. All right. The Reed family is planning a 9-day winter vacation during December or January. The destination they have chosen averages 35 snow days out of 60. Okay? If the Reeds would like to avoid snow on at least 4 days of their vacation, should they go to this spot or choose another spot. Okay? They would like to avoid snow. Okay, 4. So now they're probably going to set up a 9, and they're going to set up a proportion just like this and see. How does that equalize? I think it makes a lot more sense to say, all right, we want 5, if they want to avoid snow at least 4 days, all right, and 35 days, it snows during 35. So they're okay with having 5 days out of 9 be snow days, all right? So we could see if those are equal, but they're going to set up the ratio like I first did here. Understand the problem. 35 days out of 60. They at least want 4 that aren't snowy, okay? So 35 out of 60 equals x over 9. We do our cross multiplying. 5.25 are going to be snowy. All right. Subtract the predicted number of snow days from the total vacation days, and you get around 4 days. Look back. They should choose a different location if it's likely to snow more than 5 days during that, which will not give the reads at least 4 days without snow. So it's likely to snow more than 5 days, so they're not going to choose this spot. Okay? All right, guys, make sure we're thinking about it.